my name is Anderson Ngelambong. So I'm from the Faculty of Hotel and Tourism Management, UiTM or Universiti Teknologi Mara, Penang branch. So I think my topic is more on the sampling size, because when I saw the presentation or the session yesterday, so I believe that most of you, you have come across the earlier part of the research process, which is I think mostly like research gap, what is research, by Prof. Noel, and also the how to do a survey instrument, quantitative survey instrument by Dr. Nuhidayah. I think we had a nice session yesterday. So for today, this morning especially, my session is on the sampling size or sample size. So before I start, I will share my screen. Yes. Okay, so this is the presentation outline. So before I proceed further, into my presentation, so I would like to inform you about the introduction or a brief introduction to the sample size, and the criteria for determining sample size key considerations, Craig-Morgan sample size table, G-Power software, a tool for the sample size determination, oversampling, and also the conclusion. So the next slide, I will briefly introduce you about sample size. So normally in quantitative study, so my session will focus on the sample size for quantitative study. So normally in quantitative study, the researcher usually determines sample size based on ambiguous approaches. So approaches that doesn't have any statistical evidence to it. For example, researcher might be tempted to determine a sample size based on intuition or convenient. So you just have this feeling that, this number is good. Maybe you just say that 100, but then there is no statistical evidence to support that 100 is enough for your research. So a researcher named Fowler, Fowler 2013, he argues that such sampling practices are all inappropriate and misguided. So in research, to do empirical research, so you have to have a good justification of sample size. It's not just based on feeling, but it has to be based on statistical evidence also. So the next one is, although there is no conclusive guidelines exist in determining the appropriate sample size for a study, a good sample size should consider the absolute size of the sample, instead of depending on its relative size. So this is stated by Bill 2017. Thus, with reference to research methodology literature, several criteria or rules rules of thumb suggested by Will 2017, Sakaran and Bugi 2016, Malhotra 2009, and Fowler 2013, were used to guide in determining the appropriate sample size. So these are the names of the famous, I think if you study about research method class, or you have the research method textbooks, I think this is not familiar name for you. I think this is the names for the expert in research method, especially for sample size. So this is for my session, I will focus on these researchers or these authors that have statistical evidence on how to determine the sample size for a research. So for example, Bill 2017, based on the criteria of precision level of the result, level of detail in the analysis, and also your budget. I think most of the popular one is Sakaran and Bugi 2016, whereby they based on the research objective, confidence interval, confidence level, variability of the population, cost and time limitation, and also size of population. So Malhotra 2009 introduced the incident rates and completion rates. So this is important also. For example, if you want to do the oversampling, so oversampling is, I think, unheard before in the research. Mostly you just do the exact number. So I think in some situation you need to do some oversampling, especially if the survey is not that not well responded by the respondent. So lastly is by Fowler 2013. So this is he add data analysis okay, and also the reliable sample size table, okay, that have confidence level and estimate response percentage. So these are the authors that have statistical evidence or support, okay, of the numbers they will presented. Okay, so what are the first one? Okay, so the first one, okay, for this session, okay, I will refer to the sample size table. Okay, most of us, okay, for convenience, we use sample size table. Okay, so there are few sample size table. Okay, you can search online. Okay, I think I will show some of the popular one. Okay, and second is the data analysis method. Okay, how what is the analysis that you choose? Okay, to analyze your data. Okay, that also influence, okay, the sample size for your research. And number three is rates of incidence and completion. Okay, this is important, okay, for you to do your oversampling. So later on, I will show you how to calculate the number for oversampling. Okay, and lastly is sample size of past studies, okay, within the same subject. So it's important for you also, okay, to know that the sample size, okay, of the previous studies that are similar to yours, so that you have that validity or conformity that you are within the satisfactory range of the sample size. Okay, so first, I just give you a case scenario, okay, how a sample size is determined. Okay, so here we have the research setting, okay, whereby this researcher or this author, okay, wanted to survey for a hotel review Facebook page. Okay, so I think Facebook page or social media is a very interesting place to capture or to collect your data. So here in this example, so it used hotel review, okay, Facebook page. Okay, so it is estimated that the population or the members of this Facebook page is 7 million. Okay, over 7 million. Okay, 7 million 0.0566 to be exact. Okay, so this you can get from the numbers. You can see the numbers of members inside a Facebook page. Okay, so then you have to go to your research model. Okay, go back to your literature review or your conceptual model. You have to know the maximum number, okay, of your independent variables going to dependent variables. So in SEM or structured equation modeling, we call this variable as exogenous and endogenous. So exogenous is similar, okay, to independent variables, but normally they just refer to as exogenous. Okay, so for this sample or this example, I stated that the maximum is 5. Okay, 5 variable, okay, going towards 1 dependent variables. Okay, and also the data collection. So here, okay, the data collection is also have a significant influence on your choice of sample size. Okay, so data collection in this case is online survey. So this is the scenario whereby you have to determine, okay, what sample size that you have to do. Okay, so here the question mark is on the sample size. So let's us see how we determine the sample size from this case scenario. Okay, so the first one, I believe, okay, most of you, okay, especially my students, I think most of you, okay, you refer to Craig and Morgan. Okay, so Craig and Morgan is very popular. Okay, it's I think one of the, I think if you go to research method or research classes, one most cited, okay, most cited author for sample size. Okay, so Craig and Morgan. So this table was made in 1970. Okay, it shows the population size and also the confidence and the margin of error. Okay, so you can see that it's up to 300 million. You can see the number that you should require for the sample size. Okay, so for this example just now, okay, as I go back to the previous slide, you can see the population is over 7 million. Okay, over 7 million, and you can see that for 7 million you should get 384. Okay, but that is based on confidence level of 95% and 5% significant. Okay, so 384. But then you can see it can increase to 9,000 over. Okay, if you want the margin of error 1%. Okay, so it depends on the researcher. Okay, you have to have valid justification. Okay, which number that you select. Okay, so normally you have to base on the reference or the previous authors. Okay, that have cite their reference. So the number one, number two is G power. Okay, and G power is getting popular. Okay, among the, I think the recent recent researcher. Okay, also cited in previous studies. Okay, mentioned that G power is popular. okay, statistical power analysis program to determine the minimum sample size. Okay, so I mentioned here minimum sample size, okay, that you have to have in order to achieve the statistical power. Okay, so this is where my minimum sample size I derive from. Okay, so it's more efficient and precise, okay, than the conventional technique, as it takes into the consideration of the number of constructs and the details of data analysis. Okay, so here you can see they introduced the number of constructs. So just now, okay, I mentioned about the variables. Okay, so sometimes we choose we say variables, sometimes we say construct. So they means the same thing. Okay, so construct, okay, variable, factor. Okay, so the number of construct means that how many independent variables. Okay, so just now I mentioned about exogenous variable, right? So I think most of the research method class, maybe you mentioned about independent variables. So how many independent variable going towards, okay, the dependent variable? So you have the arrow. Okay, if you draw your research model, okay, you have this arrow. So how many arrow are there? Okay, that is the maximum, okay, number of construct. Okay, so if you have that, okay, you can use the G power. Okay, and the details of the data analysis. Okay, so the several parameters should be considered that can influence the sample size. Okay, these include the effect size, okay, significant level, statistical power, and the maximum number of predictors in the structural model. Okay, so G power, okay, is I think is you can use it when you don't have the number of the population or the total population is unknown. Okay, you don't know the number of the population. So this is the advantage of G power because it doesn't require you to know the total population. Okay, so G power is depends on, as I mentioned just now, it depends on the number of construct and the details of the analysis. Okay, so this is the ready. Okay, this is the result, okay, from the G power. So you have a diagram like this. Okay, before that you have to go to G power software. Okay, I think it can be downloaded. Just Google G power. Okay, you can download and you can use it. Okay, so here you can see the finished product or the finished result. Okay, so this is based on the 5 predictor model. Okay, 5 predictor model whereby I have 5 independent variables going towards 1 dependent variables, or 5 exogenous variable going to 1 endogenous variable. Okay, so we have 5 going towards 1. So meaning there are 5 arrows. Okay, you should put 5 there. Okay, so as I show you here, you can see you have to fill in the box here. Okay, you have to fill in. Okay, so actually if you go to the software, okay, the software will be blank. Okay, you need to key in the input or key in the information so the software can run, okay, for you. Okay, so here you can see that the number of predictors is stated here 5. Okay, so I key in 5. This is based on the research model. Okay, based on your research model. So how many arrows, the maximum arrows, okay, going towards 1 endogenous or dependent variables. So in this case, okay, there are 5 maximum arrows, okay, going towards 1 dependent variable. So I put 5 there. Okay, the power, okay, is 80%, or in this one is 0.8. Okay, so 80%, it means 80% statistical power. Okay, that is good enough. Okay, you can go higher, you can go 90% or 0.9. But then this influence your sample size, it will be a bit bigger. Okay, so in some situation, you have to know whether you can get the enough, the adequate sample size, or is it hard to get sample size. So if it's very hard to get sample size, okay, maybe you can lessen a bit the statistical power to 80% or 0.8. Okay, but then that is the minimum requirement. Okay, so 0.8 or 80%. Okay, so the error probability is 0.05. So significant level, okay, significant level 0.05, and the effect size is 0.15. Okay, so if you run this one, okay, you have to put the test family as F test. Okay, statistical test is linear multiple regression. Okay, fixed model, R square deviation from 0. Okay, and you have to set here a priori. Okay, a priori compute required sample size. Okay, given the alpha, power, and effect size. Okay, so this is the setting, okay, used in this example. Okay, so a priori meaning that you have to determine before you collect the data. You can calculate after you collect the data, but then that is not advisable because you should determine your sample size, okay, before you collect your data, okay, not after you collect the data, okay. So here the priori is the best option, okay. So after you key in all the data or all the information in the software, you just click run, okay. So it will give you the answer here, okay. So from 5, okay, numerator here, we can see the given or the suggested, okay, sample size is 92. Okay, so 92 respondent. So it means that you have to get minimum, okay, minimum 92 respondent for the research model. So this G power is not based on total population. So it's not similar to the Krejcik and Morgan. Okay, so if you go to Krejcik and Morgan table just now, okay, Krejcik and Morgan is based on the total population. So if the total population is unknown, okay, you can refer to this software. Okay, so G power. So G power, okay, is based on the research model. So how many arrows, okay, the maximum arrows going from the exogenous variable to the endogenous variable. So in this case, the answer is 92. Okay, but bear in mind, this is the minimum sample size. Okay. So as an alternative, you can refer to this table. Okay, so this table also means the same thing. Okay, but this is the ready-made numbers. Okay, just like Krejcik Morgan, but then this is based on the PLSM or SEM. Okay, so structural equation modeling. Okay, so this is based on the statistical power of 80% or 0.8. Okay, so this statistical power is the minimum requirement. Okay, for SEM. So as you can see in the table, okay, you can see here they have the column, okay, for the maximum number of arrows, okay, pointing at the construct. Okay, so meaning that you have to look back at your research model, okay, and see how many variables are there. Okay, and this is you should get the you should take the maximum. Okay, I aware that maybe for the undergraduate, okay, maybe the model is very simple. Okay, but for postgraduate study, maybe the research model is quite complicated, whereby you have so many variables, right? So in order to use this table, you should know what is the maximum, okay, maximum numbers of arrows pointing at a construct or at a variable. Okay, so if I refer to my research model just now, okay, I say that my research model, the maximum is 5. Okay, meaning there are 5 predictor. Okay, 5 predictor going to 1. Okay, factor. So here I take 5%. Okay, significant level is 5%. And the maximum R square or adjusted R square is based on 0.25. Okay, here you can see mine is 70 here. Okay, so 70. So this is the minimum sample size if I use this table. Okay, so it's a bit, the number is a bit different. Okay, because of the calculation of the statistical power. Okay, so if you realize in my previous slide, okay, so the actual power is not 0.8. Okay, it's 0.80419 to 1. Okay, so the number of sample size will be higher, okay, if you increase the power. Okay, so the power. So if you increase a power a little bit, it will be higher. Okay, just now the table mentioned 70, right? But 70 is based on the 80%. Okay, power or statistical power. Okay, so here in this table, okay, is a bit higher, 0.80419 to 1. So that is the actual power. So I derive a bit higher sample size, which is 92. Okay, but then you can use both. Okay, you can use the G power, and also for convenient, you can use the table here. Okay, sample size recommendation in a PLSM for a statistical power, okay, of 80%. Okay, so I will give you the reference at the back of the slide. Okay. Okay, we move on to the next one. Okay, so you have the minimum sample size, right? So do you think the 70 respondent is enough? Do you think the 92 respondent is quite good for your research? But then that is minimum. Okay, so in some situation, I think in most situation, okay, you need to oversample. Okay, especially for online survey or web survey. Okay, because you have to know the non-response rate is quite high. Okay, so people not all respondents will respond to your survey. Okay, you have to remember. Okay, when you give 100 survey, maybe only 50% will come back to you. Okay, so you don't have that minimum sample size to analyze your data. So whereby here is introduced oversampling. Okay, in certain situation, you need to oversample your sample size. Okay. So although the sample size is specified by the statistical analysis program, so just now, for example, we have the G power, okay, was a precise sample size. It did not consider, okay, it did not consider the external factors, okay, that could reduce the initial sample size. Okay. So here I introduce one citation or reference, okay, an author named Malhotra, okay, Malhotra 2009, argues the need for oversampling. So don't quote me, okay, I'm not the one introduced oversampling. So you should quote Malhotra 2009, okay. So in which a much larger number of respondents are surveyed than the initial number required. Okay, this is particularly important for an web survey or an online survey, okay, where the average response rate is rather low. Okay, if you can see from the previous study, you can check, okay, what is the response rate for the online survey. Okay, so you can see, I believe, okay, it's below 50%, okay, which is half of it. Okay, you imagine, okay, if you have that number just now, 92, right, or 70, 92 sample size. But when you do the actual survey, you get half of it because the response rate is very low, 50%. So if you divide 90, for example, divide by 2, you get 45, right? So is it enough? Is it good? Is it reliable to run your data? Okay, of course not. Okay, but if you run your pilot study, it's okay. Okay, so pilot study is okay, but for actual study, say 45 is quite low. Okay, that's why Malhotra introduced, okay, the term oversampling. Okay, so how oversampling is done? Okay, this is done to anticipate, okay, any possibility of response rate, okay, being too low that may increase, okay, the probability of statistical biases, okay, which, okay, where samples are too small are less probable to be spotted. Okay, meaning that you have that actually is significant. Okay, maybe your hypothesis is significant, but because of your sample size is quite low or quite small, it doesn't detect that significant level. Okay, so that's why it's important to have a good, okay, or accurate sample size for research. Okay. Okay, while any response rate can result in bias, case Zakaria and Mugi 2016 state that too large of sample size is also problematic. So it's not good, okay, because this will lead to type 2 errors. So what type 2 errors? Meaning that if you run the test, it's significant, but then actually it's not significant, okay, because if your sample size is too large, meaning that everything will be significant, okay, because it's I think the data, the software will detect it, okay. So meaning that the sample size will influence, okay, whether it's significant or not significant. Okay, therefore the researcher should be careful, okay, when adjusting the initial sample size. Okay, so Malhotra to suggest that the statistical determined sample size should be adjusted based on 2 factors. Okay, so I introduce here 2 things. Okay, to calculate, okay, the sample size based on the oversampling. Okay, so there is a formula. So in the formula, okay, you should know the rates of incident and completion. Okay, the first is refer to the percentage of occurrence. Okay, so rates of incidents, okay, refer to the percentage of occurrence. Okay, while the rates of completion, okay, refer to the percentage of qualified respondents who complete the survey. Okay, so this is the formula. Okay, as you can see here. So this is based on Malhotra. You can go to the textbook by Malhotra. So this is for the oversampling. Okay, first we have the initial sample size. So for this example, I use 92. Okay, so the 92 is come from the G power analysis I showed just now. Okay, so the initial or the original sample size is 92. There is a minimum sample size required for the study. Okay, and the final sample size is question mark. Okay, is unknown. Okay, the final sample size. So whereby, okay, you have here incident rate, okay, divided by incident rate, okay, multiplied by completion rate. Okay, so in this case, okay, you should know what is the incident rate and also the completion rate. Okay, you should determine, okay, the incident rate and completion rate. So how we determine incident rate and completion rate? Okay, the first one, okay, the incident rate. Okay, so the estimation can be made, okay, based on the result of your pilot study. Okay, for example, okay, you have a pilot study, right? So you give the survey, okay, 100 survey to respondent. Okay, so from the 100, 8 is not eligible. Okay, So how do I know? How do you know the respondent is not eligible? So yesterday, okay, I believe Dr. Nuhidaya, okay, in one session about the how to develop instrument, okay, research instrument, she mentioned about screening question. So screening question is important. Okay, whereby you know whether the respondent is eligible or not eligible for your research. So screening question is used, okay, to know whether the population, okay, most of them, are they eligible or not? Okay, so here 8 out of 100 is not eligible. Okay, so here if you minus 100 minus 8 is 92. Okay, only 92 of the pilot study respondent is the respondent that you want, or the accurate respondent. Okay, so this represents 92%. Okay, so the high accurate percentage of 92% means that it's easy, okay, to find suitable respondent in the hotel review Facebook page. Okay, so that's on average 1.087. So how I derive to this number? Okay, you should divide, okay, 1 divided by 0.92. So the 0.92 is 92% just now. Okay, so that is the number for the incident rate. So this number you should put in the formula. Okay, so before I put that number, so I should calculate first the completion rate. Okay, so the completion rate, okay, how I know the completion rate? You should refer to the previous similar study. Okay, you should refer to the previous similar study in terms of the non-response rate. Okay, non-response rate, you can get the information from the literature. Okay, so for example, okay, based on the literature, okay, that use online survey. Okay, because this study use online survey. Okay, so the average response rate for online survey are usually between the range of 20% to 23%. Okay, this is by Natalie 2008. Okay, so this number you cannot just pick up from the sky. Okay, you should just you should get it from the literature. Okay, I believe there's a lot of papers. Okay, there are many papers on literature review, right? So you have the systematic literature review. You can search it in the Google Scholar. Okay, whereby they can advise you or suggest you the range of the non-response rate. Okay, so this is the response rate is only 20% to 23%. So you just imagine, okay, if you survey, okay, 100 respondents, or you give 100 survey, okay, 100 survey, right? So based on this literature, you only get 20%. So meaning if you distribute 100 survey, you get back only 20 responses. Okay, so that is not good, right? So that's why oversampling is important. Okay, so here, okay, the number of respondents was increased by a factor of 5. Okay, based on the non-response rate or the response rate, 20%. So 1 divided by 0.2. Okay, how I get 0.2? Based on the literature. So the lowest is 20%. Okay, that is the lowest response rate. So 0.2 come from the 20%. So I convert to the decimal. Okay, is 0.2. So 0.2 equal to 20%. So if I divide, okay, 1 by 0.2, it will give me the answer of 5. Okay, so after both of the number, we have the number for the incident rate and also the completion rate. Okay, this should be included in the formula. Okay, so the formula will help you to identify the final sample size. So I put the answer just now, okay, for the incident rate and also the completion rate, okay, inside the formula. As you can see here, okay, the initial sample size is 92. Okay, that is the original sample size. Okay, from the G-power analysis. Okay, so that's the minimum sample size. Okay, 92 respondent. Okay, and the final sample size is question mark. Okay, I haven't get the number for the final sample size, but then, okay, from my calculation, I get the number for the incident rate and also the completion rate. Okay, so for the incident rate, I get 1.087, and for the completion rate, I get 5. Okay, so this should be multiplied and multiplied by 92. Okay, so I get 500 respondent. Okay, for the 92 minimum sample size. Okay, 500. Okay, so as a result, okay, 500 respondent is the maximum sample size, okay, needed to be surveyed, okay, for this study, okay, in order to achieve the initial, okay, sample size of the 92 respondents. So the 92 respondents, okay, I measure as I refer to as the minimum sample size. So therefore, if you minus okay, 500 with 92 respondents, and you get the oversampling size is 408 respondents. Okay, it's based on the 92% incidence rate and completion rate of 20%. Okay, whereby you can see here, I need to oversample more than that. Okay, more than the 92 respondent. Okay, this is based on the 92% incidence rate and also 20% completion rate. You can see here for online survey, okay, the completion rate is very low. Okay, when the completion rate is very low, okay, you need to increase, okay, the sample size. Okay, meaning that if you distribute 500 questionnaire, so at least you get more than 92 respondents. Okay, so the figure should be between, okay, you should get in between 92 respondents to 500 respondents. So in between is a good number already. Okay, so lastly, so sample size is also based on the literature review. Okay, so you need to go to the literature, okay, that do the same study, that use the same method, okay, for you to know whether your sample size is okay or not. Okay, so the sample size of other similar studies, okay, was reviewed. Okay, you should review. Okay, you should review to determine whether the final sample size is within the satisfactory range. Okay, meaning you are in the same league with the other researcher, okay, who have done, okay, similar studies. Okay, for example, okay, based on the sample size of the previous study, okay, example maybe 450 respondent, okay, in Ali study 2019, and similar study by Abu 2017 also use 490 respondent. So you see your sample is quite similar, okay, because in your case, okay, the sample size is 500 respondent. Okay, so what happens if you get so many reference of or authors that has used the similar method, online method, right? So you can use average. Okay, and here you have two numbers, right? You have 450 respondent, you have 490 respondent. You have two numbers. You can total these two up and you just divide it by 2 because only 2 citation or 2 reference. But if you have many, for example, like 3, 4, 5 reference, we can just total up the numbers and divide it by the number of the authors. Okay, the citation, sorry. Okay, the citation. You can have that average. So you can check, you can compare whether your sample size is similar. Okay, similar to the literature. Okay, so at the end, you can go to Roscoe also for this example. For example, this research said sample size is 500. Okay, so this number is supported by Roscoe 1975. Okay, who states that this number 500 is generally appropriate for most social science research. So for social science, 500 is enough. Okay. Okay, so for conclusion, okay, so I have come to the end of my session or my topic. Okay, so after we have considered, okay, all the criteria and we have referred to the textbook, the authors, and also the previous studies, okay, who have similar method and similar topic, okay, we can conclude that, okay, the 4 key considerations of determining the sample size, for example, by using the sampling, the sample size table. Okay, the sample size table, for example, we have the Krejcik and Morgan, we have the Cohen, okay, and data analysis method. Okay, data analysis method, for example, if you use SPSS, you use structural equation modeling or SEM, and also if you want to do the oversampling, okay, you need to refer the rate of incident and completion, and also previous studies. Okay, this can help you, okay, to determine your sample size. Okay, so in this case, okay, in this case scenario, okay, the answer should be 500. Okay, so 500 is the maximum, so 92 is the minimum. So you should get in between that. Okay, so in between that is quite good enough. Okay, so these are several of the reference. Okay, several of the references that I use for my slide. Okay, you can refer to Hare et al. 2013. I believe they have the new textbook, okay, for the primer on partial least square structural equation modeling, or PLS SEM. Okay, for those who are interested to use PLS SEM, you can refer to Hare et al. 2013, or they have a recent book, okay, for this. Okay, and then just now I mentioned about Malhotra. Okay, Malhotra is for the oversampling. even to get to know more about oversampling, you can go to the text to this textbook, okay, Mahota 2009, okay, basic marketing research decision making approach, okay. And then I think you have, most of you are familiar with Krajcik and Morgan, okay, 1970. Okay, for G Power, okay, G Power you can refer to Fold et al. 2007, okay, whereby they discuss, they explain about how to use G Power, okay, in the research, okay, in the research paper, okay. So the table for the SEM, okay, sample size for the SEM, you can refer to the Cohen, 1988, whereby he talked about the statistical power analysis. Okay, so there are many choices or many textbooks you can refer to. Okay, so this is some of the good one. So that is the end of my presentation. So I hope you have a good sharing knowledge with me. So I think you can give me questions. You can email me your questions, okay, to anderson@uitm.edu.my. Okay, so thank you for participating in my session, and wish you, okay, stay safe and stay well. Okay, thank you very much for your time.